Good morning, students. Chapter 3 Trigonometry. So, in this chapter, first we are going to see about angles. Okay, the angle AOB is measured formed by two rays OA and OB sharing the common point O. The common point O is called the vertex of the angle. If we rotate OA about its vertex and it takes the position OB. So OA, it rotates about its vertex and takes the position OB. If we have like this, then OA is called the initial side of the angle and OB is called the terminal side of the angle. You see now, an anti-clockwise rotation generates a positive angle, that is the angle is positive, while a clockwise rotation generates a negative angle. That means anti-clockwise direction, if the ray, that is the initial side, rotates, that is the angle is positive. If it rotates in the clockwise direction, so the angle is negative. Then one full complete rotation in the clockwise of OA back to itself is called a one complete rotation or revolution. You see now, one full anti-clockwise rotation of OA back to itself is called one complete rotation or revolution. Okay, so to measure the angle, we will use three systems. The first system is sexagesimal system. In that, a right angle is divided into 90 equal parts. They are called degree. Each degree is divided into 60 equal parts. They are called minutes. Each minute is divided into 60 equal parts. They are called seconds. Okay, so the next one, centesimal system. So, a right angle is divided into 100 equal parts called grades. In sexagesimal system, they are called degrees. So, right angle is divided into 90 equal parts. Here, in centesimal system is a right angle is divided into 100 equal parts. They are called grades. Grades, how it will be denoted? 1 to the power g. So, the power of 1, you have to write g. So, that is 1 grade. Each grade is subdivided into 100 minutes and each minute is subdivided into 100 seconds. So, the next one, circular system. This is a very important results. We will use many branch of mathematics. We will use this system only. Okay. The radian measure of an angle is introduced using arc lengths in a circle of radius r. Using circle and using the arc length of the circle, we will measure the angle. So, that radian measure of an angle is introduced in this circular system. It will be denoted as 1 power c. 1c is called the 1 radian measure. Okay. So, we will move to the next one, degree measure. So, the degree is a unit of measurement of angle. So, if we want to measure the angle, we will use one measure, that is the degree measure. It is represented by this symbol. So, we are very familiar with this, 30 degree, 45 degree, 60 degree. So, we will write like this, symbol we will use. So, one complete rotation, we split up one complete rotation into 360 equal parts and each part is 1 degree. You see that one complete rotation is, we split up into 360 equal parts. Each part is 1 degree. It is denoted by 1 degree. So, 1 degree can be said as 1 by 360 of one complete rotation. Or full rotation la or part, that is 1 degree. So, 1 minute can be written as 1 by 60 of a degree. 1 second can be written as 1 by 60 of a minute or 1 by 3600 of a degree. Okay. You see now, the next one we are moving to classification of pair of angles. So, we will consider two angles, pair of angles, how we can call it as. The first one, congruent angles. two angles that have the same exact measurement, they are called congruent angles. Two angles that have the exact same measure are called congruent angles. Next one is a complementary angles. Two angles that have their measures adding to 90 degree are called complementary angles. So the sum of two angles is 90 degree, they are called complementary angle. The next one, supplementary angle. Two angles that have their measures adding to 180 degree. So the sum of two angles is 180 degree, they are called supplementary angle. The next one, conjugate angle. Two angles between 0 degree and 360 degree are conjugate if their sum equals to 360 degree. So they are called conjugate angles. Okay. You see now, as an important results, angles in standard position. What is it? Angles in standard position. An angle is said to be in standard position if its vertex is at the origin and its initial side is along the positive x-axis. Okay, you see now, if the angle is in the standard position means, you see now, vertex is at the origin. So, x-axis, y-axis, the vertex is at the origin and the initial side of the angle is along x-axis. Then only we will say the angle is in the standard position. Okay, you see now the next one, quadrant angles. Okay, angles in standard position, that means the vertex is at the origin and the initial side is along the positive x-axis. They are having their terminal sides along the x-axis or y-axis are called quadrant angles. You see that angle vertex, it should be at the origin and the initial sides should along the positive x-axis and the terminal side of the angles, they can be in the either in the x-axis or y-axis, they are called quadrant angles. You look at this, the first diagram, you see that here we have written two quadrant angles. Look at this. So this is the horizontal line is x-axis and the vertical line is y-axis. Okay, you see that O is that origin is the vertex now. OA is the initial side. Okay, so OA is the initial side and again the terminal side also OA. You see both the initial side and the terminal side or along the positive x-axis means no angle is formed. So the angle is 0 degree. So 0 degree is a one quadrant angle. Okay, you see now, the same thing, the angle in the standard position, what it is, the vertex is at the origin and the initial side is in the positive x-axis and see the terminal side also, that is OB also in the same position, okay, after making one complete rotation. So this is the initial side, after rotates anti-clockwise, one complete rotation is over, this OB will be the same OA, means the angle is 360 degree. In 360 degree also, initial side as well as the terminal side, it is on the positive x-axis. No angle is formed, na, it is 0 degree. After making one complete rotation, the terminal side is again at OA, na, it is 360 degree. Okay, and you see this here, your vertex is at the origin and your initial side is on the positive x-axis. Now your terminal side where it is on the positive side of y-axis. Okay, so what is quadrant angles? Angles in standard position having the terminal sides along the x-axis or y-axis. Now your terminal sides is along y-axis. So therefore 90 degree is also a quadrant angles. And coming to here, it is what the third diagram. You look at this. You see, I have drawn only the x-axis. So x-axis is drawn. Here O is the origin. Here the vertex is at the origin and the initial side what it is, OA, it is along x-axis, positive x-axis. Okay, and the terminal side OB is along the negative side of x-axis. So the OA is the initial side, and after making this rotation, OB is on the negative side of x-axis. So what's the angle is made? It is 180 degrees. So 180 degrees is in the quadrant angles. And same way, you just look at this. So O is at the vertex is at the origin, and OA is in the positive x-axis, and your OB, the terminal side, you just see that it is on the negative side of y-axis after this much rotation. So how much it is rotated? 270 degree. So this is also a quadrant angles because its terminal side is on the negative side of y-axis. So therefore the angles 0 degree, 90 degree, 180 degree, 270 degree and 360 degree are called quadrant angles. Okay, you see that. Now, see, this is divided into 4 quadrants. So, it is a quadrant, first quadrant, second quadrant, third quadrant and fourth quadrant. So, in the first quadrant, the amount of rotation, so the angle is measured from 0 degree to 90 degree. In the second quadrant, the angle is move from 90 degree to 180 degree. And here third quadrant, 180 degree to 270 degree. In the fourth quadrant, 270 degree to 360 degree. Okay, so these are the things you should know. Now I'm moving to the exercise 3.1. First subdivision. Identify the quadrant in which an angle of each given measure lies. Okay, first one, what is it? 25 degree. So first, we have to draw the x-axis and y-axis. So 25 degree. So in the first quadrant, theta varies from 0 to 25. Okay, so see that the angle is positive. So positive means you have to move the anti-clockwise rotation. So this is your initial side. This O is the vertex. What is it? Your O is the vertex, that is origin is at the vertex. So this is your initial side, and after making the rotation 25 degree, so this is the terminal side. So you see theta is equal to 25 degree. Where it lies, in which quadrant it lies? It lies in the first quadrant. Okay, come to the second one. It is 825 degree. So it is more than 360 degree. Okay, so I'll have 720 degree plus 105 degree, I can write as 825 degree. Why I write 720 degree? You see that 2 into 360 degree. That means 360 degree means one complete rotation is over. So 720 degree is 2 into 360 degree. So 2 complete rotation over for 720 degree. Plus what is remaining? 105 degree. So after making 2 complete rotation, so we have to move how much? It is 105 degree in the anti-clockwise direction. So here O is the vertex and this is your initial side. You look at this, your angle first complete rotation is over, starting from 0 degree to 360 degrees over. How much complete rotation it has to complete? 2 complete rotation. So I have completed the second rotation also. After that it is 105 degree. So if you come here, you have to move to the first quadrant. So 90 degrees over. So the remaining is what? 105 degree, 90 degrees over means it is 15 degrees. So it moves to the next quadrant. After making 2 complete rotation, so we moved 105 degree. So in the anti-clockwise direction. So you have to mention the arrow mark in this way. So this is your 825 degree. Your 825 degree, where it is? It lies in the second quadrant. This is first quadrant. Here it is a second quadrant. Okay. So you come to the third one. You see minus 55 degree. It is a negative angle. So we have to do the rotation in the clockwise. So see now here, this is your initial ray. initial side. Okay, but now you have to rotate clockwise. So how much degree? 55 degree. So one quadrant means it is 90 degrees over. So we have to move to the clockwise. So we'll move in this clockwise direction. So this is the terminal side of the angle. So this is your minus 55 degree. So minus 55 degree lies in the fourth quadrant. But now come to 328 degree. So the angle is positive. So we have to do the rotation in the, what is it, anti-clockwise direction, starting from the initial initial side. We have to move 90. First quadrant is over. 328, it is less than 360. They didn't complete one full rotation. So first quadrant, if it is over now, 90 degrees over, then it has to move to the second quadrant, 180 degrees over. Next it has to move to the third quadrant, 270 degrees over. After the remaining angle, so it has to come to the fourth quadrant. So we are moving in the anti-clockwise direction because this angle is positive. So therefore this is the terminal side of that angle, 328 degrees. So 328 degree lies in the fourth quadrant. Okay, and next one, what is it? Minus 230 degree. So what is it? It is minus 230 degree. So look at this, the angle is negative. So we have to do the what direction? Clockwise direction. So from the initial side, so that is initial ray. So we have to move the clockwise. So 90 degrees over. Next 180 degrees over. So the remaining in this quadrant, so the remaining degree will come. So this is your minus 230 degree. So minus 230 degree lies in which quadrant? It lies in second quadrant. Okay, ma'am. So thank you, students.